Hello there, thanks for watching and I appreciate you. This is a video in a series of videos showing you how to make a custom character controller that uses rigid body physics, cinemachine cameras, Unity's new input system, and custom player gravity. In the last video, we learned how to increase and decrease our camera's distance from the player, and in this video, we're going to add a ground check and introduce custom gravity for our player. But first, we need to spend some time adding some new obstacles to our test arena. Okay, now that done, we can go ahead and go over what I just did real quick. Basically, I created a bunch of cubes and I rotated them, so these have a 25-degree rotation on them, these ramps here. I have one facing each direction so we can thoroughly test our character controller. And all they're doing is they're on a 25-degree rotation and they're sticking out of the ground slightly so that we have slopes and or ramps, whatever you want to call them. Same thing over here, except these ones are a 40, 45, 50, and 55-degree incline, and they go much further into the air so that we can test our down speed basically when we go down the ramps. And then back here we just have a big long one, so, and this will make sense later why I created all these because we're going to be doing slopes in the next video. But for now we're just going to be doing some ground checks and some basic player gravity, so let's get back to that. Okay, so if you remember, we're using Unity's gravity currently. If you go back to our player, you drop this down, select your player, under rigid body, you'll see we have use gravity checked, but we also increased the drag to 4, so the default gravity setting, which you can change and everything. But I like having more control of the gravity, so we're doing a custom implementation of gravity here. And with all that said, keep in mind again that the drag is set to 4. Let's go ahead and let's play the game, let's see what happens. Let me maximize it. And if we go off random ramp here, you'll see that we go down very, very slowly. Again, that's because we have the drag set to 4, which is a very high number for the drag value. And there's going to be resistance, whether it's up, down, left, right, it doesn't matter. And we're going to implement our own gravity because that's what my game requires anyway. So let's stop the game. And let's go ahead right now and let's unselect use gravity on our player's rigid body. And with that done, if we jump on over to our project panel down here and we go to controllers, human land controller, let's double click it and open it up in our editor. Again, in our humanoid land controller script here, we're going to make some changes. I'm going to make them and then we'll come back and we'll review them together. And that's it. Now we can review what we just did. So if we scroll back up to the top, and I always forget to zoom in for you guys. Let me go ahead and zoom this in, makes this a little bigger so you can see it a lot easier. Okay, and up at the top up here, we created a capsule collider variable. It's going to store a capsule collider. Next, we created a ground check section. Under here, we have a player is grounded equals true. It's a boolean. By default, we're setting it to true. Next, we have a ground check radius multiplier, setting it to 0.9, and it's a float. Again, we serialized it so that we can change it in the inspector panel to a different value as we need to while we're playing the game. And then we set just a standard range. You can set these whatever you like. And same thing down here, a range, serialized it, it's another float, and this one we call ground check distance. Default value on this one is 0.05. And next we have a raycast hit, we called it ground check hit, and we're just initializing it with a new raycast hit. The next section is called gravity. These are all serialized fields, so we can change them in the inspector on the fly. We have gravity fall current, gravity fall min, gravity fall max, gravity fall increment amount, gravity fall increment time, player fall timer, and just gravity. Just below here in the awake function, went ahead, took our capsule collider, and we cached our capsule collider within our underscore capsule collider variable. We scroll down a little bit further to fixed update. We added player is grounded equals player ground check, player move input dot y equals player gravity, player move input equals player move. So if we go to our first one, which is player is grounded, let's go to our player ground check function, see what's happening there. So here we have player ground check. We have a float, we call it SphereCast radius, and we're setting it to the capsule collider's radius times our ground check radius multiplier. This is basically just making our radius a little bit smaller than the actual full radius of our player. Here we have float SphereCast travel distance. So this is going to get a little more complicated. Here we're taking the capsule collider. Under bounds, extents y. So basically what this is, we're taking the center of the capsule collider and we're getting the distance of the y, the height of the y from the center to the bottom. We're subtracting the SphereCast radius from basically the half height of our capsule collider, and then we're adding our ground check distance. So I'm going to draw this because this is going to be a lot simpler to understand. And this is all being used to actually send our final ground check. So what we're using is we're using a Physics.SphereCast because we're basically sending an invisible sphere down below our feet to see if we hit anything. And we're starting it from our rigidbody position, which by default is going to be our center position. It's going to be our SphereCast radius in size, the actual sphere itself that we're sending downwards. It's going to use the SphereCast radius. We're going to send it down. Anything that we hit, if we hit something, we're going to store it in our ground check hit variable, which we set to global. And it's going to travel as far as this, as far as our SphereCast travel distance. We'll come back and we'll review all this in just a minute. We'll go a lot more in depth. I'll draw it all up for you so you can understand the breakdown of how everything adds up. But next, let's go down to our player gravity section here. And let's take a look, see what this function does. So this is going to return a float. And when we come to this function, it's going to check see if we're grounded. If we are grounded, we don't need gravity, so we're going to reset our gravity values back to 0, back to the original values. Gravity is going to be nothing. Our gravity fall current is going to be reset to our gravity fall minimum. If we are not grounded, then we are falling. Okay, so gravity is going to be applied if we're not grounded. Our player fall timer is going to start counting. It's going to start counting minus our time dot fixed delta time. If our fall timer is greater than 0, then we're going to come into this loop and we're going to do another check. If our gravity fall current, if our current fall gravity is greater than our maximum, then we're going to come in here and we're going to increase our current by our increment amount. And one quick thing to note here is our gravity values are negative values. So this is actually going to seem backwards, but since they're negatives, this is actually going to need to be greater than our maximum for it to be increased. Once it exceeds our maximum, then it's not going to increase it anymore. Because again, these are negative values, so things are backwards. It's a little confusing. But yeah, moving on. Outside of the loop, if player fall timer is greater than 0, then we're going to come down here after we do this. If it increments, that's great. If it doesn't, that's fine too. Our player fall timer, we're going to reset our timer to our increment time amount. And then our gravity is finally going to get set to our current fall gravity amount. And then we're going to return it. as just gravity. And then finally, I came down here into the player move section. I made it return a vector 3. I turned this, instead of directly modifying player move input, I created a local variable called calculate player movement, and I have this function now returning that value. And again, if we go up to fixed update, you'll see that we are then storing that value back in the player move input. I just like keeping things sectioned out. It gets less, you can just come to fixed update and basically see the flow of how things are happening. And there's just a lot less guesswork involved. And it's easier to track things down when you have a problem and you need to go look to see what's happening. Okay, now let's go back down to our GroundCheck function and we'll break that down so we can understand exactly what that's doing. And on your screen now, you'll see the actual snippet. I'll put it on the screen. And this is a terrible drawing, the best I could do, of our character controller. It's a capsule collider, right? We're looking at it from the side perspective. So like, for example, we'll give it a little smiley face here. Alright, so the first line, we have a float, SphereCast radius is the name of it. It's the capsule collider radius and the GroundCheck radius multiplier. So it's very simple. You have the diameter, just the full width, and you have a radius, which is half the diameter. So we're taking the radius and we're multiplying it by our GroundCheck radius multiplier, 0.9, because we don't want our actual GroundCheck multiplier to be as wide as our player. That'll cause issues if it takes up the same space as this. So we want it to be just a little bit smaller. Hence the 0.9, we're going to multiply it. That'll give us 90% of the total radius. So if our radius, say our diameter is 1, our radius is then 0.5, and we want 0.9 of that 0.5, that works out to 0.45 obviously. So our SphereCast radius is actually 0.45, and we'll store that as a float, so it's going to be 0.45f. And to go into just a little more detail here, I wanted to interject and explain why exactly our SphereCast radius needs to be smaller than our player's collider radius. So here we have our player again. It's a capsule, very poorly drawn capsule, but a capsule nonetheless. And all a capsule is a sphere, so a circle that they split in half, and then they put a cone, or a cylinder in between it. So at the top half you have half of sphere, and at the bottom half you have half of sphere. And if you take a SphereCast that's the same size, or the same radius as this, right, so you have a SphereCast, and you place it down here, then what's possible is you're going to get overpenetration on the sides of a collider, and that SphereCast is going to trigger easily. It's going to trigger anytime you bump into something. And that's not okay, because all that SphereCast is supposed to be doing is it's supposed to be detecting whether we're on the ground or not. Hence we're asking, is player grounded? Or player is grounded, true or false, right? So we don't want it triggering yes or no if we're hitting something on the sides. We only want it triggering on the bottom. So the solution to that is to make the SphereCast just a little bit smaller so that it's actually inside the player a little bit, so that if a collider overpenetrates the player's walls, then it doesn't trigger. And the whole reason we're using a SphereCast instead of a raycast is so that we get a bigger area underneath the player so that we don't have to do multiple detections with multiple raycasts. Alright, next line is our SphereCast travel distance. Alright, let's undo all of this so that we can start over with a clean slate. Okay, so now our SphereCast travel distance is just that. It's how far our SphereCast needs to travel to get to the ground, or where the ground should be, so that we can return whether we're actually grounded or not. So a SphereCast is it's a sphere, so we're just going to draw a 2D circle, and it's going to spawn right on the center of our player. So right there. So we're going to have a SphereCast. And if you remember, it's going to be 0.45 radius. So that's the SphereCast right there. And so we have this distance here, which is a sphere. So this is going to be 0.45. And then we need to find out the distance from here to the bottom. And that distance is going to be our capsule collider bounds extents.y. That right there is that bounds extent.y. And on our character, that's going to be 1.5 units, meters, whatever you want to refer to it as, because our entire character height is 3, right? So 3 divided by 2 is 1.5, pretty simple. And then what we're going to want to do with that is we're going to want to take our capsule collider bound extents y value, which are 1.5, and then our SphereCast radius, and we're going to want to subtract that from this. So we're going to be left with 1.05. So this is actually going to be drawn here. It's going to travel 1.05 down. It's going to stop right about here. So that our SphereCast radius is right there. But that's just going to be at the very, very bottom of our character collider, okay? That's going to work out to basically perfect measurements. We want a little bit of a buffer there, and that's what our ground check distance is. Our ground check distance, I'm going off memory here, I believe is 0.05, so we're adding that on. So it's actually going to end up traveling 1.1 units or meters, or again, whatever you're using for your values there. And what that's going to do is that's going to move that just slightly below our player here, so that we're checking for the ground there. So in our last line, you'll see we have return, Physics.SphereCast, rigid body position, which rigid body position is the center here. It's going to be that right there. Our SphereCast radius, 0.45. That's going to be the size of the SphereCast. Our vector 3 down, what direction do we want to travel? We want to travel downwards. Where are we going to store it as? We're going to store, if there's a hit, we're going to store that hit in our ground check hit variable. And then how far do we want to travel? We want to travel our calculated SphereCast travel distance value, which again is going to be 1.1. So we want to travel 1.1 units. Now that we've talked about player ground check, I want to talk about player gravity a little bit more too. So the first time we come through, if you remember, player is grounded, we've already set that to true. So the first time after we start our game up and this goes through the code, it'll come down here and it's going to make sure that our gravity is 0 and that our gravity fall current is our gravity fall min, which our gravity fall min is negative 100, right? So after that, it's going to go through, it's going to return that 0 gravity, because that's what we're returning is gravity. And next time we come through here, and if we're not grounded anymore, then what's going to happen is our player fall timer, which the default value on that the first time through is 0.0, right? We set the default timer to 0.0. And we're going to subtract our time.fixed delta time, which our time.fixed delta time is the time between fixed updates, how often the physics updates are actually run, the physics loop. By default, that's 0.02 seconds, which is 50 times a second. That's going to subtract from there. It's going to do a check if our player fall timer, which we just subtracted, it's 0.0 the first time, we just subtracted 0.02 seconds away from it. So our player fall timer is indeed going to be less than 0.0. So what do we want to do? We want to increase our gravity because we're still falling, right? So our gravity fall current, which is our current rate, which currently is our minimum amount, right? It's 100. If it is greater than our gravity fall max, which again, these are negative values, so our negative fall max is negative 500, our fall current is negative 100, so negative 100 is more than negative 500, then we're going to take our gravity fall current and we're going to add our increment amount to it, which our increment amount is 20, right? So our gravity fall current is then going to become 120. We're going to come down here, we're going to reset our player fall timer to our gravity fall increment time, which is 0.05, so every 0.05 seconds, we're going to increment our gravity amount. And then after that, since we now have our calculated gravity fall current, we're going to assign that to our gravity value, and then we're going to return that value. So if we're going to come through this again, because we're still not grounded, the second time we come through our player fall timer, we're going to subtract -2 from it. It's going to be 0.05 this time. Negative 0.02 is not going to be enough, so it's going to skip this. It's just going to say, hey, again, it's 100, and that's going to happen once more until we come back through once again, and then finally our player fall timer is going to be less than 0.0, because again, our time.fixed delta time is 0.02, and our gravity fall increment time is 0.05, and what we're doing here is we're effectively counting down from that 0.05 to a negative value. So the first time we have a negative value, we come in here, like timer's up, let's add more gravity, and rinse and repeat. We just keep adding more gravity, more gravity, more gravity, until we hit our gravity fall maximum, which I've set to -500. So there's a million different ways we could do this. We don't have to do it this way. We don't have to set a timer and then just keep looping and looping and looping and incrementing it time after time again. Like I said, there's a million different ways we can do this. The reason why I chose to do it this way is because this is also how I'm doing my coyote time and my jump buffering for our jump. And I like to be consistent in my programming. So if I'm using this in one place and I understand how it works, then why not use it in more places so it's easier for me to just keep going. So with all that said, if you have any questions, please do ask them in the comments. And I think it's time for us to go ahead and go do a playtest. So if we jump on back over to Unity, and in Unity I'm going to maximize on play, and I'm going to play it. And here we are. Let's go ahead and see if our gravity's working. Appears to be working just fine. That's good. Let's go to the top, jump off one of these tall ramps. At the very top, gonna spin around, and down we go. You can see it's increasing as we're falling. That's great. It's working as intended. Everything seems to be working as we want it to. Obviously, our ground check's also working because we're not getting any gravity on the ground. Otherwise, we'd be getting a lot more friction. Even though we have friction set to 0, we'd still be getting some collider issues with that much gravity being applied. Everything seems to be working fine. And with that, this video is over. I'm sorry it was kind of strung together over quite a few days and I don't script these. So the thought process and everything is just all over the place. I'm sorry it's so messy. Hopefully this makes sense. Again, if you have any questions, ask them in the comments. And that's it for this video. The next video I'm really looking forward to because I put a lot of effort into figuring out a solution for the problems we'll be addressing. And what we're going to be fixing is slopes. If our player goes down a slope now, he'll just kind of skip down it, and we don't want that. I'll also be showing you how to properly decrease player movement speed when going up a slope and increase it when going down a slope. And we'll also be implementing a method of limiting the angle of the slope that the player can actually climb up. These methods I've made I haven't seen used anywhere else, so I'm kind of excited to share them. The best part is that this is all going to be accomplished with only about 5 lines of code. So with all that said, bye for now. If you're feeling generous, leave a comment down below. I want to read what you're thinking. Let me know if you have any questions or recommendations. I'd also appreciate it very much if you liked the video. And if you're feeling extra generous, it'd blow my mind if you subscribe to the channel. Being new to this and putting these videos together takes a lot of time and effort. Thank you for any and all participation and support. I look forward to continuing this in the next one. See ya.